River crossing. Four people A, B, C, and D need to get across a river, and the only way to cross that river is by an old bridge, which holds at most two people at a time. So, being dark, they cannot cross the bridge without a torch, of which they only have one. So, each pair can only walk at the speed of the slower person. They need to get all of them across to the other side as quickly as possible. So, now we get the speeds of every person. A is the slowest and takes 10 minutes to cross, B takes 5 minutes, C takes 2 minutes, and D takes 1 minute. So what is the minimum time to get all of them across to the other side? So the idea here is that just from an observation, let's say that this is our bridge, it makes sense for the fastest person to accompany a slower person because once they get to the other side, suppose A and D go together, D can be sent back in the fastest time possible to get the next person across the bridge. But notice that that creates some sort of, complexity because if D were the only dedicated messenger, then it kind of wastes moves, right? Because effectively every time we go back and forth, only one person gets to the other side. On every crossing of the bridge, we want to get as many people over as possible. So it doesn't make sense to keep using D. It makes sense, therefore, to have a designated messenger on both ends of the bridge. The two fastest people are going to be the messengers. They're going to be the people ferrying people to and from. That way we can have the smallest time. And to illustrate that idea, consider that we start with A, B, C, D. Who should go across first? Well, if D accompanies the slowest person, then that's kind of a wasted move because we still have to then accompany 5. So 5, because A is the slowest person, it makes sense for the second slowest person to go with A because if D were to go with A, it's going to take 10 minutes. But if we had B go with A, it would also take 10 minutes, but we got the two slowest people across. So it makes sense that when we're traveling, A and B should go together, right? Just by that observation. So then that means who can go? Well, it means that what's remaining is C and D. They're the only two people who can cross, given that A and B should go together. So on the first crossing, C and D go together by this logic. And the crossing will take 2 minutes because C takes 2, D takes 1. So now we have A, B, and we have C, D here. Now, who should we send back? Well, obviously, we should send back D because D is the fastest. Leave C here, and we can establish C to be the messenger that's going to fetch D at the end. So what I mean by this is send D back. Sending D back gets us A, B, D, and we have C here, and it took us only one minute. Now, we established that A and B should go together. So therefore, send A and B over. When we send A and B over, we use up 10 minutes. But those 10 minutes were well spent because we got the two slowest people across with just one move. So that was a very optimal choice. Now, it makes sense to send the fastest person on this side to come and fetch D across. That's what I meant by having two messengers on both sides. So send C back, in which case we get CD and AB. So this took us 2 minutes, and we have CD come across together so we can get AB, CD. And this took us 2 minutes of time. So summing this up, what do we get? Well, we have 0 here. So 2 plus 1 is 3, plus 10 is 13, 15, and 17, getting us a final answer of 17.